Okay, so this is Mr. Martin. These are the video notes for section 3.7 for Geometry Honors. Um, this is a really important section. We're going to talk about some theorems that if you're not looking for them, you may get to some problems where you have no idea how to solve them. So really make sure you understand these and start looking for the angle side theorems to help you solve proofs and algebraic geometry problems as well. So the first theorem is if two sides of a triangle are congruent, then the angles opposite the sides are congruent. So we're basically looking at an isosceles triangle, and we know that two sides of the triangle are congruent. So if we know that AB and CB are congruent, then the angles opposite them, so the angle opposite AB is angle C, and the angle opposite BC is angle A. So if we were given, or we could prove somehow, that AB was congruent to CB, then our conclusion would be that angle A was congruent to angle C. Now, this also works the other way around. That's theorem 21. It says if two angles of a triangle are congruent. So now we've got two angles of the triangle. We'll draw the same triangle, ABC. But now we're going to start with the angles congruent, and then the sides opposite them. So go across the triangle, those would be congruent. So we would just flip-flop our given and conclusion. So if we were given angle A was congruent to angle C, then our conclusion would be that AB is congruent to CB. And again, start looking for this in other figures where you may have some overlapping triangles, or you may have two triangles that share a side, but you also have one large triangle that would be an isosceles triangle. So, you know, if you're given the two sides, two angles might be congruent, or if you're given two angles, two sides might be congruent. So really, this leads us, and I kind of mentioned this in a previous video, these two theorems lead us to two ways to prove a triangle is isosceles. So by the converse of the definition, which we actually did in the last video, if at least two sides of a triangle are congruent, then the triangle is isosceles. Or by a variation of the converse, if at least two angles of a triangle are congruent, then the triangle is isosceles. So many of you, you're going to use theorem 21 to get the two sides, and then you're going to use this first method every time, but you don't necessarily have to, because as soon as you get two angles of the triangle congruent, you can prove the triangle is isosceles. Now, we also have the negations of theorem 20 and 21, which say if two sides of a triangle are not congruent, then the angles opposite the sides are not congruent, which makes sense, but here's the important part. And the larger angle is opposite the longer side. Okay, so if I have a triangle here that's not isosceles, so here's triangle ABC, and I know that A is not congruent to BC. I'll show that with tick marks. And I know we're not supposed to do this, but if we go by how these sides look, since AB is shorter, again, we'll just assume that it is, than BC, then the angle opposite it is going to be smaller than the angle opposite side BC. Okay, so since AB is less than BC, angle C would be less than angle A. Let's make sure I got that right. AB is smaller than BC, so angle C opposite angle side AB. Yeah, okay. So the smaller angle is opposite the shorter side. All right, and then sort of the converse of this as well. If two angles of a triangle are not congruent, then the sides opposite the angles are also not congruent, and the longer side is opposite the larger angle. So again, same type of idea, except we're starting with the smaller angles. So again, I'm going to just mark that this angle is smaller than that angle. We'll show that with tick marks. the one tick mark smaller than the two tick mark. But again, we're just going by assumption. So since angle C is less than angle A, so the side opposite that one, AB, would be less than the side opposite the larger angle, BC. So if you have questions about those, make sure you ask me during class. I know a lot of times I forget to ask you if you have questions, so take the initiative and check in with me. Okay, so moving on to something a little bit different, let's talk about the median to the base of an isosceles triangle. So if I have an isosceles triangle, we'll make these my legs. I've got A, B, and C. So I also know that these angles are congruent. And then I need a median. So since it's a median, I know it divides this side into two congruent segments. So if I have this median, if you want to pause the video and see if you can figure out what else we have, go ahead and do that now. So you can see from these tick marks, so we know it's isosceles, so the legs are going to be congruent. We know since it's isosceles, the base angles will be congruent. Since we know this is a median, we know these two pieces will be congruent. So I could prove the triangle on the left congruent to the triangle on the right by side angle side. And you know, if you're thinking ahead, we could see that these two angles are going to be congruent. And we can see that these two angles also make 180-degree angles. So if I have two angles that add up to a 180-degree angle and they're congruent, we know they have to be a right angle, which means that this median would also have to be an altitude. So the median to the base of an isosceles triangle is also the altitude to the base. Okay, and if we can get these two triangles congruent, I know that this angle is going to be congruent to this angle, which would make it the angle bisector of the vertex angle. It is also the angle bisector of the vertex angle. Okay, so some things to keep in mind. We're not exactly going to use these as theorems. I may ask you to prove them, which you should be able to do by getting the triangles congruent and using a few more steps, like CPC-TC. Okay, so let's move on to some examples. I know that angle E is congruent to angle H. So if we're looking ahead, I can see in this big triangle, if we forget about everything else except looking at triangle DEH, I see that it has two congruent angles. So since it has two congruent angles, what else do we know is congruent? Well, we know that the sides opposite them are going to be congruent. So this side over here is going to be congruent to this side over here. We'll get that in the proof in a minute. And I also know that EF is congruent to GH. And I'm trying to prove that DF and DG are congruent. And we'll probably end up getting those as corresponding parts. So if you want to follow along, feel free. Otherwise, pause the video and then you can restart it and compare your proof with my proof. And then if it's different and you can't figure it out, you can ask me questions next time you see me. So we've got our two pieces of given information. So given, and we already talked about the fact that since these two angles are congruent, I know that DH is congruent to DE. Now the reason would be if two angles of a triangle are congruent, then the sides opposite them are congruent. We're going to use a symbol abbreviation. So we're going to go if, and then I put two little congruent angles in there. If two angles of a triangle are congruent, then the sides opposite them are congruent. Okay, and when we use the other one, we'll just flip those symbols around. So if two sides were congruent, then two angles are congruent. And that gives us everything that we need to prove triangle DEF is congruent to triangle DHG by side angle side from steps 1, 2, and 3. And once we have 1, 2, and 3, are the triangles congruent, I can prove that DF is congruent to DG by CPCTC. Right, so again, make sure you use the symbol form unless you really feel the need to write out the whole thing. So if two angles of a triangle are congruent, then the sides opposite them are congruent. Alright, so at this point, I'm going to get this problem set up for you, and then I'm going to pause the video and write out the solution. So if you want to pause the video too. So it says prove that the bisector of the vertex angle of an isosceles triangle is also the median. So you have to kind of interpret what's going on here. We know we have an isosceles triangle, and when you're given an isosceles triangle, it's going to be very important that you specify some piece of it so that you know which are the congruent sides and which are the congruent angles. So in this case, when I write my given, I'm going to write triangle ABC is isosceles, and then I'm going to specify with base BC. Okay, if I know that this is the base, then I know these have to be my congruent sides. I know B and C have to be my congruent angles. Alright, it says prove that the bisector of the vertex angle. So now that I know that BC is my base, I know that AC, I'm going to put a point down there, or A is my vertex. So I'm going to draw the angle bisector of that vertex angle. So I know that ray AD bisects angle BAC. So the bisector of the vertex angle, I have that. I have the isosceles triangle, so those are my keywords. Those are my given, that's my given information. And I want to prove that it is also, so I want to prove that AD is a median. Okay, so if you notice here in the given, I have it as a ray, but in the conclusion, I have it as a segment. Because remember, there's a line that goes through these 2 points A and D, and there's also a ray associated with that line that starts at A and goes in the direction of D. There's also a segment that goes between A and D. So we're kind of referring to two different parts of that line, the ray and the segment together. So at this point, go ahead and pause the video and see if you can work out the solution, and then restart it and you'll see the completed solution. Alright, so here's the completed solution. So if you notice up to step 6, really what we're doing is getting the triangles congruent. And a couple things I want to point out here. You know, obviously we've got angle 1 congruent to angle 2. If a ray bisects an angle, it divides it into two congruent angles. And then I've got AB congruent to AC. And notice my reason here. It's if a triangle is isosceles, then the legs are congruent. Okay, and that's the reason I want you to use. Anytime you know it's an isosceles triangle, you can say that the legs are congruent. Now for angle B congruent to angle C, I could have also used if a triangle is isosceles and its base angles are congruent, but since I already have two sides of the triangle congruent, angle B and angle C are the angles opposite them. So this reason's a little bit shorter, that's why I chose to use that one. If two sides of a triangle are congruent, then the angles opposite them are congruent. Then we can get the triangles congruent by angle side angle, which means that BC or BD and CD, notice my corresponding order when I name those, BD and CD are congruent by CPCTC. And once I have those two sides congruent, I'm going to use my altered form of the converse of median to say that AD is a median if a segment extends from the vertex of a triangle and divides the opposite side into two congruent segments, then it's a median. Again, make sure you write down any questions and ask me in class, and we'll see you next time.